It is not a waste to feed new panel boards with a 200% neutral from existing switchboards, even if those switchboards' existing feeders do not have 200% neutrals. There are benefits to using a 200% neutral. These include increased capacity, reduced voltage drop, and improved safety. Firstly, increased capacity is a significant advantage. A 200% neutral provides double the current capacity of a standard neutral. This enables more loads to be connected without overloading the neutral conductor. Secondly, a 200% neutral helps reduce voltage drop on the neutral conductor. This improves voltage stability and ensures that equipment receives the proper voltage. Thirdly, a larger neutral conductor provides a lower impedance path for fault currents. This reduces the risk of electrical shock or equipment damage. There are also some considerations to keep in mind. These considerations include cost, space requirements, and code requirements. Firstly, installing a 200% neutral may initially be more expensive due to the larger conductor size required. Secondly, the larger neutral conductor will require more space in conduits and panel boards. Thirdly, local electrical codes may require a 200% neutral for certain applications, such as commercial buildings with large electrical loads. It is generally recommended to upgrade the existing feeders to also have a 200% neutral if the new loads being added to the building are significant and will require a 200% neutral. It may be acceptable to feed the new panel boards with a 200% neutral while leaving the existing feeders with their current neutrals if the new loads are relatively small and the existing feeders have adequate capacity. It is very important to consult with a qualified electrician to determine the specific requirements for a project and to ensure compliance with all applicable codes. Electrical systems, especially those involving 208 volts, require careful planning and execution to ensure safety and efficiency. When renovating an existing building, the question of whether to upgrade the neutral conductors in the panel boards is a critical one. The neutral conductor plays a vital role in carrying unbalanced currents back to the source, and its proper sizing is essential for preventing overheating and ensuring the safe operation of electrical equipment. A 200% neutral refers to a neutral conductor that is sized to carry twice the calculated unbalanced load. This is often done in situations where there are significant nonlinear loads, such as those produced by electronic devices, which can generate harmonic currents that add to the neutral current. While the existing feeders may not have a 200% neutral, there are still several reasons why it may be beneficial to install one in the new panel boards. One primary benefit is the ability to accommodate future growth and changes in the building's electrical load. As technology advances and more electronic devices are used, the harmonic content of the electrical system is likely to increase. By installing a 200% neutral, a system will be better equipped to handle these increased harmonic currents without overloading the neutral conductor. Another benefit of a 200% neutral is improved voltage stability. When the neutral conductor is undersized, it can cause voltage drops and imbalances in the system. This can lead to equipment malfunction and reduced efficiency. A larger neutral conductor helps to minimize voltage drops and maintain a more stable voltage supply to the connected loads. Safety is also a major consideration when it comes to neutral conductor sizing. An overloaded neutral conductor can overheat, leading to insulation breakdown and potential fire hazards. By installing a 200% neutral, the risk of overheating is reduced, and the overall safety of the electrical system is improved. There are also some potential drawbacks to consider. The most obvious is the increased cost of the larger conductor. A 200% neutral will require a larger conductor size, which will be more expensive than a standard neutral conductor. There may also be additional costs associated with the installation, such as the need for larger conduit and fittings. Space constraints can also be a factor. A larger neutral conductor will require more space in the panel board and conduit. This may be a concern in existing buildings where space is limited. It is important to carefully consider these factors before deciding whether to install a 200% neutral. It is also important to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. In some cases, local electrical codes may require 200% neutral for certain types of installations. For example, commercial buildings with a high concentration of electronic devices may be required to have a 200% neutral to handle the increased harmonic currents. Even if a 200% neutral is not required by code, it may still be a good idea to consider it as a preventative measure. By installing a larger neutral conductor, the system will be more resilient to changes in the electrical load and will be less likely to experience problems in the future. Ultimately, the decision of whether to install a 200% neutral depends on a variety of factors, including the size and type of the electrical load, the existing infrastructure, and local code requirements. It is important to carefully consider all of these factors before making a decision. Consulting with a qualified electrician is essential to ensure that the installation is done safely and correctly. The National Electrical Code, or NEC, provides guidelines for sizing neutral conductors. NEC Section 220.61 covers the requirements for calculating the neutral load. In many cases, the NEC allows the neutral conductor to be smaller than the phase conductors, but there are certain situations where a larger neutral conductor is required. For example, if the electrical system serves a significant amount of nonlinear loads, the neutral conductor may need to be sized to carry the harmonic currents. The NEC also provides specific requirements for neutral conductors in certain types of installations, such as healthcare facilities and data centers. These requirements are designed to ensure the safety and reliability of the electrical system in these critical applications. When working on an electrical renovation project, it is important to carefully review the NEC and any applicable local codes to ensure that the installation meets all requirements. It is also important to document all calculations and decisions related to the neutral conductor sizing. This documentation can be helpful in the future if there are any questions or issues related to the electrical system. In addition to the NEC, there are also other industry standards and best practices that can be helpful in designing and installing electrical systems. For example, the Institute of Electrical and Electronics Engineers, or IEE, publishes a number of standards related to power quality and harmonic mitigation. These standards can provide guidance on how to minimize harmonic currents and improve the overall performance of the electrical system. There are several steps that can be taken to reduce harmonic currents in an electrical system. One common approach is to use harmonic filters. Harmonic filters are devices that are designed to block or reduce harmonic currents. They can be installed at the source of the harmonic currents or at the point of common coupling. Another approach is to use transformers that are designed to minimize harmonic currents. These transformers have a special winding configuration that helps to cancel out the harmonic currents. It is also important to use properly sized conductors and equipment to minimize voltage drops and improve the overall power quality of the electrical system. By taking these steps, it is possible to reduce harmonic currents and improve the reliability and efficiency of the electrical system. When designing an electrical system, it is important to consider the potential impact of nonlinear loads and harmonic currents. By properly sizing the neutral conductor and taking steps to mitigate harmonic currents, it is possible to ensure the safe and reliable operation of the electrical system. In summary, while the existing feeders may not have a 200% neutral, there are several reasons why it may be beneficial to install one in the new panel boards. These include increased capacity, improved voltage stability, and improved safety. However, it is important to consider the increased cost and space requirements before making a decision. It is also important to consult with a qualified electrician to ensure that the installation meets all applicable codes and standards. The electrical work should only be performed by qualified individuals who have the necessary training and experience. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid electrical shock and other hazards. Before starting any electrical work, it is important to disconnect the power supply to the circuit being worked on. This can be done by turning off the circuit breaker or removing the fuse that supplies power to the circuit. It is also important to test the circuit to ensure that it is energized before starting any work. A voltage tester can be used to verify that there is no voltage present in the circuit. When working with electrical wiring, it is important to use properly insulated tools. This will help to prevent electrical shock if the tool comes into contact with a live wire. It is also important to wear appropriate personal protective equipment, such as safety glasses and gloves. When connecting electrical wires, it is important to make sure that the connections are tight and secure. Loose connections can cause overheating and potential fire hazards. It is also important to use the correct type of wire connector for the application. Different types of wire connectors are designed for different types of wire and different current ratings. When installing electrical equipment, it is important to follow the manufacturer's instructions carefully. This will ensure that the equipment is installed correctly and safely. It is also important to make sure that the equipment is properly grounded. Grounding provides a path for fault currents to flow back to the source, which helps to prevent electrical shock. After completing any electrical work, it is important to test the circuit to ensure that it is working properly. This can be done by using a multimeter to measure the voltage and current in the circuit. It is also important to check for any loose connections or other potential problems. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. A qualified electrician has the training and experience necessary to perform electrical work safely and correctly. They can also help to ensure that the installation meets all applicable codes and standards. It is important to choose an electrician who is licensed and insured. This will protect you in case of any accidents or damages that may occur during the work. You can check with your local licensing board to verify that an electrician is properly licensed. You can also ask the electrician for proof of insurance. When hiring an electrician, it is important to get a written estimate before the work begins. The estimate should include a detailed description of the work to be performed, the materials to be used, and the total cost of the project. It is also important to ask the electrician about their warranty policy. A reputable electrician will stand behind their work and offer a warranty against defects in materials and workmanship. Remember that electricity is a powerful force that can be dangerous if not handled properly. It is important to take all necessary precautions to avoid electrical shock and other hazards. By following these safety tips, you can help to ensure that your electrical work is done safely and correctly. The installation of a 200% neutral is not necessarily a waste, even if the existing feeders do not have one. It offers benefits like increased capacity, reduced voltage drop, and improved safety. However, it also presents considerations like cost, space requirements, and code compliance. A qualified electrician can assess the specific needs of the renovation project and determine the most appropriate solution.